Today we have a beautiful trick from C that is basically like writing or using binary literals for using macros, and you can use binary literals and any literal. I'm gonna show you the binary literal one. Any base literal, you can literally do base 3 and it's gonna work. So for now, let's do binary literals on C without compiler support. So in other languages, for example, let's say Python, I don't use so in Python you have this 0b prefix. So let's say if you say 0001, so it's not gonna do that, right? So Python thinks it's an octal, and it suggests you to do an octal. Now if you do 0b, you can see that it is 3. Let's shift it by 1 and it's 6, right? So it's the double, it's the multiply by 2. Okay, we know the basics. Now the question is, why would you need binary literals in your day-to-day life? So that's a good question. So if I do and let's say let.c, and what happens is that for some literals, for some flags, let's say you have a function, or let's say you have an IO control function, and you give it the file descriptor and basically the mode. So let's say the mode is 0. Let's say the mode, generic mode, right? And now what you have to do, let's say you have the mode, and you have to make it as though that this mode is gonna run with a mask. So you end it with a mask. So let's say the mask is defined as a macro, which is, let's say it is mask, right? And the IO control, that's how. But if you don't have, if you are making your own masks or your own bitwise operations, you can't just do, let's say if you want to mask it with a bit shifted left 3 times, and then the lowest 2 bits are 1. So if you want to mask it like that, it's gonna be real easy. But if you don't, you have to convert it. So 0 0 1 0 1 1 is basically 11. So you have to guess what the number is. So if it's like 16 bits long, then you have to have 16. You have to know. So you can basically you have to know the binary bit positions, bit status, bits turned on or turned off, and you can basically mode it with this, and it's gonna be super easy because you know the individual bits. So if you want to do that in Python, it's gonna you already have it. But in the C compilers, for the major compilers, which are basically GCC or Clang or MSBC, if you are in fucking Windows, so it doesn't matter. So it doesn't matter. What? I didn't mean that. No. Let's say I need you and love you. And let's see if it's working. So I've written I originally got the idea from 4chan, and I refined it, adopted it, and made it simple. That only works with 8 bits, and it can work with, as many bit width as you want, but you have to manually do that. I'm gonna show you why. So in this file, there's support for only 8 bits. So since it could be done recursively easily if macros supported recursive definition, but if you do recursive definition on macro, it gets painted blue. What is painted blue? I'm gonna drop you a Wikipedia link to learn to get an idea of what is painting blue means in CP processing. So anyway, these are 8 bits. Now what we do at this, so let's say you have this 0. So first of all, we need to translate the strings into real numbers. So it's really easy, since C, the char, which is basically 8-bit integers, 8-bit signed, I don't remember if it's signed or unsigned, so it's basically yeah, it's unsigned integers, or unsigned 8-bit integers, which basically stores the Unicode value of, or ASCII value, I guess, the ASCII value for the number. So so it starts off from 0 and goes up until 9, until 9. So what you have to do is that you dereference it, so you get the integer that the chars pointed to, and you subtract it by 0, and you get the offset, which is equal to the number you type. So in this case, it's gonna be just ones and zeros, but if you want to add more base options, you could do 1 to 9, and for fx you have to find it out to how to translate it into real numbers. So base 2 is really easy. So at the first step we have is that we basically have one, so let's start with 8. So this is the first step, and it is nested functions. So first of all, if you want, like, you have 8 bits, and the most significant, the highest most bit is turned on, then it's gonna shift it by 7, and then it's gonna recursively or nestedly apply binary R with 6. So you basically have 7-bit long bit string, then you binary R it with the shift, binary R it with 6-bit long, then 5-bit long, and so on, and you basically binary R it with each step, and what you get is this. So you have so for convenience, we basically put a stringify operator that will basically turn any tokens into a string. For now, we have these zeros and ones, and you can basically type it literally, and it will turn it into string and do stuff. So this is a wrapper function for A8. So at the first, print, and the reason I'm not gonna type, I'm gonna show you more methods on how to step by step do that, and how I got to do that. I got to do that because I don't have my left hand, unfortunately, so I have to just look at the code definition I made a minute ago, and let's see. So first we have this, and now this is 1 1, you can shift it by 1 1 and 0, and we see if you compile it, and if you compile it and run it, it's 6. Look at that. And if you shift it, so it's gonna be 12, right? 1. So shifting again by it's gonna be 12. So yeah, you basically get the idea of how we did it. And in the future video, maybe I will try to implement more base, maybe base 3, if that's cool enough. So that's it for this quick freaking tutorial.